Gradients, tangents and normals. I almost feel like saying oh my at the end of that. Right, differentiation, copy the learning objectives down. Once you're done, hit play again. Okay, so one of the things we can do with the differentiation, we can use the derivative to find the equations of the tangents and the normal to a curve at a given point. So if we have our curve, tangent intersects with the curve at a specific point, just at one point only, which means that the gradient of the curve at that point is the same as the gradient of the tangent. So the gradient of the curve, dy by dx, is the same as the gradient of the tangent at that point. Okay, so we can differentiate to get that. And the normal is this line that intersects the tangent at 90 degrees, okay, perpendicular to the tangent. Hit pause, make a sketch, the tangent and the normal, and copy the information down. Once you're ready, hit play again. Right, example. Find the equation of the tangent to the curve y equals x cubed minus 3x squared plus 2x minus 1 at the point 3, 5. Well, let's start by writing our equation. Y is equal to x cubed minus 3x squared plus 2x minus 1. We're experts now at differentiating term by term. So differentiate x cubed, we get 3x squared. Differentiate 3x squared, so it'll be minus 3 times 2, 6x. And differentiate 2x, we get 2 plus 2. Now at this point, 3, 5, the gradient, dy by dx, is equal to 3 times x is 3 squared minus 6 times 3 plus the 2, which is 27 minus 18 plus 2, so 29 minus 18, 11. So our gradient is 11. Now hopefully you can recall the formula for the equation of a straight line, which is given by y minus y1 equals m times x minus x1. Very useful. So we can sub in for the gradient m and the coordinates x and y. So we have y minus 5 is equal to 11 x minus 3. Simplify, so we go y minus 5 is equal to 11x minus 33. So we could say y is equal to 11x minus 33 plus 5, which is equal to 11x minus 28. And that's our equation of the tangent. So hit pause, copy the example down. When you're ready, hit play and we'll look at another example. Okay. This time it says find the equation of the normal to the curve y equals 8 minus 3 root x at the point where x is equal to 4. So they've only given us the x value this time. We haven't got the y value. We will find that. Just sub the x value into this equation. First, let's find the gradient at this point. So y is equal to 8 minus 3 root x. Easier to differentiate if we say y is equal to 8 minus 3 x to the power of a half. So dy by dx, constant disappears, so we've got minus 3 times a half x to the power of minus a half. So if we simplify that, we've got minus 3 over 2 x to the power of minus a half. So at the point x equals 4, the gradient dy by dx is given by minus 3 over 2 4 to the power of minus a half. Now So minus half makes it seem a bit tricky. If we write it as minus 3 over 2, minus a half, so it's going to be times 1 over the square root of 4. So that's equal to minus 3 over 2 times 2. Minus 3/4. Now this is the gradient of the tangent. But we want to find the equation of the normal. So the gradient of the normal is going to be the negative reciprocal of that. So dy by dx is going to be equal to 4 over 3. Okay. Now we've got our x coordinate, but we haven't got a y coordinate, so we need to find that. I just change to a blue pen. So if we say at x equals 4, y is equal to 8 minus 3 root x, which is equal to 8 minus 3 square root of 4, which is going to be 8 minus 3 times 2, 6. So our coordinates are given by 4 and 2. And so our final bit then is to find the equation of the normal, and we use our formula for the equation. I'm just going to do that over here. And we've got our equation, which is y minus y1 is equal to x minus x1 times m, the gradient. So subbing in, y minus 2 is equal to our gradient 4 over 3 times x minus 4. Simplify. Well, if we multiply both sides by 3, we get 3 brackets y minus 2 is equal to 4 brackets x minus 4. Expand and simplify. 3y minus 6 is equal to 4x minus 16. So we can say that 3y is equal to 4x minus 16 plus 6 equals 4x minus 10. Nothing wrong with that. You can leave it in that form, or if you want to write all three terms on the one side, you can have 3y minus 4x plus 10 equals 0. That's fine. Either one of those is acceptable. So hit pause, copy the example down. Once you're done, hit play again. We started here, so this is 1, then we moved on to here, 2, and then we finished over here, 3. So hit pause, copy it down. Once you're ready, I've got a couple of questions for you to attempt. Okay, exercise 12F. Just got the 6 questions. Won't take you very long at all. So I shall attach the questions to the assignment. Good luck.